New truck is almost, well, it's getting there. I took care of some of the issues that I've been having. I gotta figure out why this is happening. And if we... Yeah, I had a feeling it was that. Alright, so that's happening because of the collisions being... because the collisions changed. So because we don't simulate the physics until they hit until they're grounded, I might need to do that. Like check to see is grounded at the beginning, like while at begin play. But I think it might also not be a problem, so I'll worry about it later. Whee! Okay, so this is happening here, but the main problem one is going to be right now we've got that all kind of worked out for the most part, but the main big problem is the city map. And you'll see it in a second here. Just gonna go like this real quick.
Numbers are useful. Playing a fixture.
This one's the interesting one. So we can definitely see the problem. So I'm gonna change them up. So at the moment, if we go over to them, they're going to be a very specific thing that's looking for overlaps. And we don't want that to be an issue here, right? We want to check to see whether or not this is a static mesh. So overlapping component is check if overlapping component is a mesh, static mesh, or is a mesh, yeah. Mm. Okay. Wait. What? No, this is just supposed to be return. Fucking chat, Jupiter. Oh, Copilot crap. It's like every now and then Copilot just does the wrong thing. Interesting. Interesting. Oh shit. You forgot you had these? Well, thank you for the biddies, man. Why did you not show up on your first message for some reason didn't show up on my regular chat there. Weird. I think this is not overlapping correctly. And a prime sub. And a prime sub. All the subs and the biddies. How was the rest of your stream today? I think I was like getting off. Like I had to go right around the time when you were leaving anyways. Oh. Oh. Seemed like you were having a good stream. The Twitch was really active today for your stream. I was a bit surprised though. You had like 10 people in there. Ugh. So this isn't actually executing. So let's do this. Edit project settings. Maps and nodes. Take this and we're going to do the city map. Do 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 do. It was fun. I trolled everyone by leading up to providing the best advice for a 100K job and how to get it quickly. And then I ended a stream right before I shared it. Got the trolls back. Nice. Hey, if it works, right? Oh, this is on hit. I don't want on hit. I want overlap. Hmm. Oh, it's on character hit still. Heading out for a bit. Have a good stream. All right. Have a good one, man. Have a good weekend, by the way. Not that you really get weekends, you know. Being self-employed will do that to you, but hopefully you have a good one. So this is the problem here. It's not the cast isn't working. Yeah, so their overlap is not hitting because my overlap is hitting. That's annoying. Hmm. Huh. What are the collisions on this? Yeah, I've gotta adjust this. What I'm thinking I'm gonna do is switch this over to be more like the target character in some ways. But I don't know. I'm not sure how I want to fix this yet. Because what I could do, this would work. Is I could do um, yeah, just like this, and this would be BP hittable, right? But I don't think I want that. I want to keep these pedestrians as light as humanly possible. So I do like this, but then we've got to do more of this with them. So let's just do that. While we are here, we're going to just do that. Okay. Wait a ding dong moment here. Interesting. Do we do that or do we work on the target? You know what? For now, I think we work on this. We do this. Let's fix this so we can do a release. Because it's been a while since we've done a release, and I think we've got some better ragdoll situations and performance optimizations that we can take care of here. Okay, so the pedestrian needs to be rewritten, but the hittable character is pretty much doing everything we need within a specific reason amount, right? Um, Actually, it doesn't really do anything that we care about other than the set physics stuff. We can move the set physics stuff, I think, into the actually, I don't even think that we want to do that. Okay, so sorry. First things first, we want to get rid of this because it's just getting in the way. Then here, this is only registering the one overlap, even though it should be also causing an overlap with the mesh, which is a problem because the overlap with the mesh is what we care the most about. On character hit. One, I don't think, oops, I keep doing that. I don't think that there's anything that we really particularly care about for on character hit because they're all, yeah, they're all pedestrians, so we can move that. On overlap begin. There we go. So we need to only trigger when we hit them, when we overlap with the mesh, which is a problem because of many things. There's many problems here. Okay, so the capsule collision here is a pawn. This is just overlap all. Then physics body. Pawn. This we can do custom. Don't care about these. And if we say ignore, I think that fixes the problem. Guess what? Guess what? It doesn't fix it. It absolutely does not fix the problem. You know. That's kind of annoying. Oh, wait. I bet this is the problem right here. Let's try it. It's not. God damn it. Actually, is it? Let's do this. Okay, there we go. It's colliding. But it might be colliding wrong because I don't want it to collide on the truck. I want it to collide on here. So if we come over to here and we go to the capsule here, we scroll down here, make sure that collisions are correct. Vehicle overlap. Vehicle good. Hey, that's working. Then why is it not working here? Why is this not creating the dynamic overlaps? Oh, wait, because of that skeletal mesh bullshit that I did. Beautiful. Sweet. We can make a a thing today. Okay, so the most important thing is that we can make sure that our FPS is not dog shit. It's damn near perfect. Minus like a couple things that we'll need to change out here. Maps. I do not want this. Edit. Project settings. Maps and modes. Okay, so I want to change the collision box to be a little bit smaller, I think, because I think that might actually be nice. So the collision box is pretty large, and I think that we want to make this a little bit smaller. Let's see what happens. Yeah. That ramp, eh? I think I do need to clamp like the amount of multiple that we can max out at, because sometimes they just fly a bit too much. Although, yeah, it's not necessarily a bad thing. Ooh, did you see that? There we go. Beautiful. Okay, so let's test out one more map. What we're going to do is we're going to go over to the city blockout map. And this one here, we're actually going to start testing using this. But I want to delete all of these, right? So all the targets, I just want to delete them. Right now there's 13 targets. Let's not have 13 targets, right? So what we're going to do is we're going to go to AI, test spawner. And I want to have a viewport, and then we're going to do a sphere. And this sphere, actually, I guess this can just be a collision sphere. Sphere collider, right? It shows the thing. Then here we go to collisions, and we just want no collisions. Then we want editor only, right? And then on here, oops, event construct, we want to take in anything that we have for the sphere, right? Actually, is there something better? No, it's definitely an on construct thing. So we take in this here and we want to do the radius there, spawn radius. Here, spawn radius, get. And then we grab this sphere, right? Actually, I guess this would not be editor only then. There we go. What we want to do is do sphere radius to this. Then if we drag one into the center here, we can see the radius in which the sphere is going to happen. And then we can do spawn radius, and we can adjust this to have them spawn in a specific radius. There we go. And we want, say, 25. What the... It didn't spawn any of them. Wait. Is this broken on the other one then? Did I just break it? No, working here. What the fuck? Why is it working here? Oh, wait, I know why. Oh, silly me. We need a nav mesh. Do do do. Is it this? No. Nav. There we go. There we go. Mwahaha! Look at all these places I can get to. Uh, 11, 10, 9, 8, 7, 4, heck. 4, come on, come on, come on. There's 2 more. Yeah! Woot woot! Alright, so time attack is the one that I'm going to want. 26, okay. So 26. So we're going to go to time attack and we're going to update time attack now. There it is. And I believe there's 26. There is 26. There's 100 of them now. I don't think we want 100. Let's do 26. Oh, 26 gives me more than I really wanted, eh? still don't like that. She went a flying. Oh, I went right through those two. Oh. There we go. Okay. Ugh. Everything seems to be working now. That's good. Let's rename this to target spawner. Beautiful. Okay, so I guess now the idea would be to do... Would be the next idea here. Hmm. It's bad. I don't even know what to do next. I guess we're good with Ragdolls now, and now it's on to oh, I'd need to install Maya. I don't think I've got it installed. I do not have it installed. I forgot to install Maya. Do I install? I don't have ZBrush, Maya, or Blender installed right now. I only have Houdini installed. Mm. What do you want to work on? Anybody in chat have ideas? Because I've mostly got the ragdoll stuff in place. We could do AI stuff. Like the walking and whatnot. That could be interesting. No, yeah, mass. Hmm.
Hello, everybody. Welcome back to the stream. Yesterday, the stream ended quite abruptly by this maintenance of my internet provider. I was warned before, but I forgot. And 1 a.m. sharp, boom. Yeah, you don't really see the units. It's like one blob of units. I don't really like this. I think we can do much better with the system that we have. And one part of it is this avoidance. It's called avoidance, that are not touching each other. They're sort of avoiding each other. That's definitely something you see here. And you can do like a lot of different things with this system. That's something I also want to like in that official example with the large entities thingy. Free and free. Let's make this a different one, like the I don't know the.
I think we have it enabled. Let's go to city map. We'll hit play. Because I don't think they bump into each other. But they do not avoid this one here. Yeah, so I want them to walk around that. So if we go down to AI, there's we've got that. I think it's this one that we're actually using. Here's the avoidance. Let's take a look at what we've got here. Obstacles. Is that what it would be? It would be navigate obstacles? Yeah, navigate obstacles is there. But avoidance does not work on this. Unreal Engine mass entity avoidance. Hmm. Ooh. Destroy entity performance. I was wondering about the performance of removing and adding entities, as it feels like these might be quite expensive. Not going to worry about that. How to change between two different behaviors. Technically, sequencer already uses what to do. A bare minimum movement processor to show how to set up processes. Small unique entities, small unique identifiers that point to a combination of fragments and tags in memory. Entities are manually and manually a simple integer ID. When transform, velocity, and damage data. Interesting. Data only. That entities can own and processors can query on to create a fragment inherit from. Okay. With mass fragments, each entity gets its own fragment data to share data across many entities. We can use shared fragment. Shared fragment is a type of fragment that multiple entities can point to. This is often used for configuration common to a group of entities like LOD or replication settings to create a shared fragment inherit from. Interesting. Tags, an empty use script struct that processors can use to filter entities to process based on their presence/absence. Create a tag inherit from as tags. Mass enhanced its API to support UWorld subsystems. In our processors, this provides a way to create encapsulated functionality to operate entities. First, inherit from UWorld subsystem and define its basic interface alongside your function variables. Like, I get this, but like, real engine mass entity avoid avoidance. Is it because the truck doesn't affect nav? Is that what it is? I thought it was supposed to though. If set nav mesh will not be generated underneath the surface of the geometry. Ah. What was it? It was it's just like, no. Mm-mm. Well, I think that's kind of working. They're just not avoiding enough. Time the agent considers. Okay, let's try this. That's better. That's better. Definitely better. Definitely getting better. Okay, so I think this is fine. Okay, so now what we want to do is we want to adjust this where if vehicle get speed. Wait, how was I getting the speed here? If forward speed is less than 0, just return. I think that's just gonna let me phase right through them, right? Oops. I have to restart for this. Okay. Unreal Engine state tree avoidance.
Hey guys, Space Marine 658 here, and today I am going to be talking to you about state trees. They are a relatively new addition to Unreal Engine, and I thought I would kind of go over them because there's some really cool features in them, especially now there's been some changes made since they were originally released. Now these are subject to change because of course they're still listed as experimental. They're really, really cool, and there's a lot of cool things you can do with them. So let's go ahead and just get started off. You're going to want to actually enable them inside of your plugins. So go ahead and type in state tree. There are two here that you're going to want to select. So it's gameplay state tree and then state tree. Go ahead and check mark both of those. You have to restart your editor, and what you do, you'll be back here. All right. So once you've done that, you will be able to go here inside of your AI board and hit state tree. Now I'm going to create a new blank once I kind of show you what it looks like starting off, and then we'll kind of walk through mine. And so what you'll want to do is up here at the top, there's state tree component, and that's what you want to select. And then go ahead and give it a name. For now, since this is just going to be deleted, I'm just going to call it ST placeholder. All right, so when you first load it up, you'll see here you've got a very blank template. You've got something called a context actor over here, and then you've got the context actor class. So basically what a context actor is it basically gives the state tree information about what actor may be running this tree. You can be very specific, or you can do a parent class. So you can even leave it as just a plain actor. The problem is the more generic you leave this, the less information your state tree has about the actor actually running the state tree. So for me, I'm going to go and select my base ship AI since that is the parent class that I have. And then from within here, now let's say I want to actually use this actor context somewhere. There's a few different ways you can use that. I'll show that later on once we actually walk through some examples of states and tasks. But let's go ahead and look at the rest of the UI here. So we have three things: parameters, evaluators, and global tasks. So what parameters are basically things that you can include inside of your state tree that can give it a little bit of information for whatever reason. So as an example, let's go here and let's actually reference our fleet manager. So we have a fleet manager object here, and we can give it a name. We'll say let's call it manager. And then we could select one directly from in world, or there are ways to set this based inside of your actual. Okay, you actually can't set direct actors. Oh, that's interesting. I've never actually tried to set direct actors. So yeah, let's go ahead and clear this out. What you can do instead then is inside of your individual actor, you can actually set this as a target. So let's actually show that in a slightly different way. So I have my main actor here with its own state tree component, and I've just got a blank vector parameter here that I've set to 000. I don't really use the parameters much because you can't pull or push information through them, but they are great for setting any kind of defaults or anything that you want for your state tree to have. So let's talk a little bit about how to get a state tree on your actor. So that's pretty simple. You just add the component here. So you just add and type in state tree, and that will add it here to your actor. And then from there you select the actual state tree from this little drop down here. going back to the state tree. And so that is your basic way of getting your, actually open up the one we're working in. So that is a parameter that you might be able to have. So let's go ahead and move this. We've also got a thing called evaluators and then global tasks. So what evaluators are is you can create evaluators within your project. And so for example, here I have an evaluator called player tracker. The way you do that is inside of here, you just right click, go to blueprint class, and then type in evaluator. And you'll see you have a state tree evaluator blueprint base. If you go ahead and click that, you can create an evaluator. And basically all an evaluator is you've got three options. You've got tree start, tree stop, and event tick. So basically this is something that runs separate from your actual tree itself, and it just gathers information you need to make evaluations. So this will grab, states that your AI has, or for example, here I'm tracking the current player's location. So whatever kind of information that you need your tree to have, this is one way to do that. Now, when you're creating these evaluators, something you're going to want to know is that to get these to show up here, to not just have them in your evaluator, you need what's known as categories to be listed correctly. So as you can see here, I have this category that says output, and for this one, I have it that says input. Now, to actually have these show up that way, you have to have that exact name. If you type it in differently, they actually won't show up here in this section. But as you can see, since this one says input and these one says output, this got an in and an out here. What this lets you do is actually reference things within that evaluator task to actually do things based off of whatever you're passing in and pulling out. So as an example here, my evaluator takes in an AI context ref, so that's a reference to the current AI that it is running on. And it actually, because I got it listed as that actor, it's then using that information to go in here and it's saying, hey, off of that AI context ref that you're passing in, give me the orders, give me the current actor location, give me the current waypoint, and give me if the current movement is completed. And so with that, all of that information gets passed back to the tree, and now I can access this in other sections. So think of this as a way to pull in data to your tree. Now let's go ahead and talk about global tasks. Now global tasks are similar to evaluators in that there's something running on the tree itself and not any individual state. But they're different in that tasks are more specifically, very specific. Let me go ahead and like, for example, so we got our wait task here. So with a global task, these are things that you want running all the time that maybe, is not specific to any one state. For example, you might have your AI check the time of day. So that your AI, wants to know if it is a certain time of day, I'm going to know to do these things. But it's not something that necessarily your AI character might have anything on them to track that. You have like two here. But they're different in that tasks are more specifically, very specific. Let me go ahead and like, for example, so we got our wait task here. So with a global task, these are things that you want running all the time that maybe, is not specific to any one state. For example, you might have your AI check the time of day. So that your AI, wants to know if it is a certain time of day, I'm going to know to do these things. But it's not something that necessarily your AI character might have anything on them to track that. You have like a level blueprint that has a time of day tracker, right? And so this task can just hit that level blueprint and go, what time of day is it? And if you reach a certain point, then you could either fire off a state or you could trigger something else like switching your trees. So if you want to go from daytime tree to a nighttime tree or something like that, as a great example in Minecraft, spiders during the day are very calm, peaceful, and won't really attack you unless you attack them. But at night, they do come after you. This is a very, very good example where you might use that. So you have a global task checking the time of day. If it is during the day, you run one tree. If it's during the night, you switch trees. Now, when you're switching trees, this global task will have to be on both trees, but it would allow you to switch between the two. Let's go ahead and remove that there. And as an example here, now that we're kind of talking about tasks in general, inside of tasks, you have things called functions. And let's actually show to create a task if you want to follow along. You do the same thing as you do with the evaluators, except you type in task. And what you'll have here is a state tree task blueprint base. Go ahead and click that and give it a name depending on what task it's doing. So within each task, you're going to have 4 functions. You've got interstate, exit state, tick, and completed. And what these do is basically every time your tree's tick runs, whatever state you're on, or if it's a global task, it just runs by default. And it tries to fire one of these tasks. And let's say, for example, we got this wait task there. The wait task does an event tick. So what that does is it checks the delta time, minuses it from the current duration, which is what we set here. Whenever we added it, there was an option to set current duration, and that's because we have that over here. So as an example, let's go ahead and put in our wait task. So we have this duration that we can set, or we can base it off of something. So if we want to set it off of some other value, we can do that as well. But once we've selected whatever duration is, this will actually just minus it to count that time down. And then, as you can see here with tasks, you don't have to have that category. Now, there are times when you may still want that category because you can use that category to clarify some things. For example, we've got these current durations and durations. Now, if you have a very complex task, you may want to have a few different things, or if you wanted to bring anything in, for example, the ship here, it just helps to clarify the different sections of the task. But the event interstate fires anytime you enter the actual state of this task. So for a global task, this is just on tree start. And then exit state fires anytime you leave that state. So once your different states transition fires and it moves from one state to another, that is when the exit state will fire. But yeah, so for example here, I'm just checking the duration. Once the duration is completed, I call a succeed task. So what this does is inside of here, each task can either succeed, fail, complete, or tick. And so let's actually go take a look at that. We also have an event. So there's an event that can be called to trigger a transition. So there are ways to trigger these to force them to change from within your actual character itself. But yeah, so we have on state complete, on state succeeded, on state failed, on tick, and on event. Now, for anything that is sort of a variable that can change, most of the time I find that doing a conditional on tick is usually the easiest way. So for example, here I got this waypoint travel. Basically, my ships will just go from point to point to point. Basically, I just check if they are within a certain distance of that point, so less than or equal to the evaluator's the evaluator's pull in current location of the AI, and then the current waypoint for that AI, its location. And I just basically go, is the current location less than or equal to the target location distance of 1,500 Unreal units? If that is the case, then I also want to look at, is the current waypoint completed, which is something I set inside my AI when I come to a full stop. If both of those are completed, then this succeeds. So what this will do is this will say, hey, this was successful, all conditions were met, and so it moves on to the next state. Now, it doesn't necessarily have to be the next state. you can have it do next state, but you can also have it say that the tree itself succeeded or the tree failed. So if you want to have trees within trees, you can have them nested in such a way that if this is like a routine, so if you're doing goal-oriented, what's the second half? Basically goal-oriented AI, this could be basically a daily task that your AI is doing. You can have like 10 of these. And let's say this is what the first one called, you can have it succeed or fail, and then based on that, choose a different tree. That is one of the ways you could do that by transitioning here. Or you can go to a different state. So you've got the root state and then all the different states. The cool thing with this is that you can actually go to any state within the tree. You aren't required to go up to the parent states. And so you can go to anywhere in between. So that's kind of how a task transitions. Now, within this, we're kind of talking about tasks in general. Tasks are meant to be sort of leafed out like this because they are doing separate things. And the idea is your transitions should move your state you should move from one state to another with transitions. And what this allows you to do is sort of guide your AI. So for example, here for my patrol, this is a state that's actually known as a group. So it's not actually doing anything itself. It's just looking for interconditions. If those interconditions are met, it then runs. And so it says, hey, I'm traveling from waypoint to waypoint, and then I'm waiting once I receive it or once I get to waypoint, and then I go and find the next waypoint. And then this repeats. Now, the only time this exits is if the orders change. So one thing I haven't talked about yet is interconditions. Interconditions are how you get from your root into any of the child states. Now, the way I have mine set up is at the top I have a group, which there are 4 different kinds. We'll talk about that here in a sec. There are 4 different types of states and roots, and the top level states to me are always groups.
I'm not a big fan of his tutorial right now. There's a stand and there's the follow path. I kind of wonder if this even needs to be here. CG follow path. All right, well we're gonna try something. It does need to be there. Okay. Can we just add a Okay. Type state. Interesting.
Because those are sort of a general idea of what the AI should be doing. And then within those, you have the actual states that are doing the actions. And so what I do is my root doesn't have any interconditions because it is literally just grouping all together this set of actions. In theory, as
It's not really what I want.
Hello, ladies and gentlemen. My name is Christian, and I hope you are well. So the world in my game is coming around nicely. We've got a couple of quests now, but it's very, very empty at the moment. There's nobody walking around. And even when we did have people walking around with the bandit quest where we kill people up here, they just stood still. So I figured now was the perfect time to start looking at adding some really basic AI. Now, there's thousands of packages out there to handle AI control and make them do things, but I'm going to go almost back to the beginning, and we're going to do it using Unreal's built-in tools. But we're not going to use the behavior tree this time. I've used the behavior tree for years. It works. It's okay for some things, but when you're doing state-based logic, you really can't beat a state tree. So in today's tutorial, we're going to implement a really basic Unreal state tree just to have a random person walk around. And if you attack them, we're going to make them run away. So something really, really basic, but a nice little addition to the game that we can add in. And it'll be a great time to start getting into state trees. So let's get started. So the first thing we want to do when we get into state trees is we need to enable the plugin, and it's a built-in one with Unreal, so it's fine. I'm going to go to Edit Plugins, and I'm going to go State Tree. It's a built-in plugin to Unreal, so you don't need to download anything. You're going to need both enabled, and then we'll just hit Restart now. And once it's restarted, we can jump straight in creating the state tree. So we're going to come to our content drawer, and I'm going to go into my content folder, I'm going to right-click, and I'll create a new folder, and I'll just call it AI. Inside here, I will right-click, I will do Artificial Intelligence and State Tree. I'm going to make sure I choose State Tree Component Schema. You can also just click this one up here. I'm going to call it S. T for state tree, and I'll just call this random roam, because that's all we're going to do. We're literally just going to make them randomly roam around the particular village, not really doing much for now. And in the future, we can improve upon it and give them smart objects where they can go up and sit on a bench and stuff like that. Really sell the illusion that this NPC is actually doing something. I'm going to open this up. So if you've never seen state trees before, it might look a little daunting at first, but they are actually really easy once you get into it. We've really got it broken down to 3 places. Over on the left side, you have where all your variables go. This is where you add all of your parameters that you want to use inside the state tree, all of your evaluators, which is where you go off and grab other variables for checking data, such as is the player currently alive, or what is the current NPC's current speed, something like that. And then global tasks, which we're not going to touch, but that's a task that you want to be continuously checking. It could be, is the NPC dead, something like that. In the middle, you have your state tree. This is where we're going to build all the different folders and the logic to actually drive our AI. And then if I click on a node, at the side you have your typical details panel. You can set the details for the particular node you clicked on and add conditions and other bits like that. So let's start with something really basic and make the NPC move around. So what do we need? We need a way to tell our state tree, tell this NPC to move somewhere. So the first thing we're going to do is we're going to populate the context. So the context, if we hover over it, so it's the one who's going to be using this state tree. You could just keep it as an actor and it will pass all the variables to the actor. If we put any variables on our specific character,
I don't have a context. They got rid of context. Huh.
such as movement or something like that, if we tell the state tree specifically what type it is, it can better use it and you don't need to cast it. So in my case, I have my NPCs here. So if I click on this guy here, we have a NPC shopkeeper and it's a type of ALS NPC in my case. So you will probably have an NPC of your own. I'm going to come in and I'm going to open up the schema here and you'll see we've got a context actor class. So I'm going to come and set mine to my ALS NPC myself. And the only difference that has done now is it means every time we want to use the context actor to do anything, such as get your current position, get if you're alive, anything like that, we don't need to cast to it because it's already got the correct. So let's start with something really basic. Let's make the AI just walk around somewhere random. So how do we do that? We need to add states in here, which
Wait. His state tree is very different than mine.
tasks which go off and action things. So we want to create a new task. At first, we're going to create a new state. So I'm going to click add state at the top, and we need to name. So I'm going to call it what's a random location, just like that. But you'll see we've got a warning symbol here right now. And what this is basically saying is each state here needs a transition of where.
Oh, wait. Yeah, because if I go like this, it will probably change. Yeah. Okay. So, engine.
Hey all, so welcome to the today's tutorial. Today we will see an interesting topic. It's called the zone. This class is responsible to spawn the actual AIs. But we have different type of fragments. So if you will explore the matrix map, there they have using the different type of fragments there. So but for the for the sake of this tutorial only, we are just using the mass actor fragment. Next, we want the crowd visualization, the AI which will be spawned, it will the movement to be synced, and avoidance. Like if there are more than in a certain area there are more than 2 or 3 players, then they can avoid each other using this module. What else? Steering, we can add, like if we will use the vehicle one, then we need steering one, else we not. Smooth.
Oh, wait. What was this? Zone graph navigation. I don't have it. That's not here. Oh no, it is. It's right here. Okay.
Next condition sync. Actually, these are very important, so you can go through those. Okay, now go back to the map in which, so in the lane profile it is 0. To the default, the ordinance. Next, go to the state tree. So it's kind of same like a behavior tree. So state tree, save. So this is the root. So first we have to tell them like why we are using it. So we have to set a schema. So it will be the mass behavior. So I'm just setting the mass. And now we have to see, this is the evaluator. Like these are the data which it's need to go forward. So in the evaluator, I am adding because we are using annotation tag. So zone graph annotation tag. So just select it and add a state here. And I will go to the transaction, go to the state name, and where I want to go, I want to go to the root. So it will be a loop. And it will be the find vendor target. So these are the 2 things. Path follow. So make sure that you are setting that it won't show up to press defined. Go back to the compile and save, and that's it. And by default, it's using the like the third sheet to click on which you want to know in Unreal. Just let me know. And
Hello everyone and welcome back to part 3 of our NPC AI series, where we take a look at the Mass AI plugin and how we can use it to create NPCs that are dynamic in our environment. Now in the first 2 parts we've set up our zone graphs and our NPCs we spawned in, but we're now going to go through the process of making them move around and avoid each other and avoid us, the player too, so it looks more natural and gives a much more lively feeling to the environment. So let's get started and take a look. So the last time we were here, we've got our zone graph set up, we've got our data assets spawning in, but we're now going to make it work and make them move around using state trees. Now you have to use state trees for your Mass AI system, they don't work with behavior trees. So to do this, all we're going to do is we're going to go back to our NPC config, and we're going to add a new trait, we're going to add a state tree trait. If you open this up, you're going to ask you for a state tree. Obviously say none. You can click on this and you're going to choose a new state tree. And we'll name this one, maybe you see here, NPC state tree. And you're going to click mass behavior. Okay, it's in there now. So if you want to open that up, you double click on the thing there. You just want to make sure that your schema is set to mass behavior. It should be, because we set it from the creation menu, but it should be there. Okay, so the first thing you need to do is, well, let me explain what you're seeing here first of all. So in the middle, we've got this actual state tree. State trees are just another form of behavior trees, indicating how AI will navigate and move around and do stuff and transition between different states. But it's what mass uses to handle this. On the right hand side, you've got details panel, which you when you select new states and things like that, you can change the settings. On the left hand side, you've got your different parameters and like variables, things that you can change on the state tree and manipulate it. So the first thing you do is make a new state for this. So click on add state, and we're going to do this one as wander. So this will be them just wandering around. And then we're going to go on the right hand side and you'll see tasks. And we click on new task. And from the empty folder, you're going to go to ZG for zone graph, and we'll do path follow. As you can see, we're going to do find wander target. We'll do that. So find wander target first of all, and this task, if you expand open and expand open again, you'll see you can assign what tags you want to use. So it's going to find a wander target inside the zone graph that you've assigned to it. So we're going to do pedestrian and high class. Minimize that, and we're going to add another task to it, and this next task is going to be path follow. And we're going to open this up, and we are going to change the target location to ZG find wander target, and then wander target location. So basically, it does this task first, and it sends that task.
Did I do that? Yeah, okay, I did.
Result over to the CG path follow. So it'll follow along the path. Movement style, we'll leave it as invalid. Speed scale, we'll leave it like that as well. Now with state trees, you do have to take what happened after the state's finished. So once it's done this wander and does this, you'll see it's missing transition. We just want it to restart. I just keep going in a loop. So you can go to transitions on the right hand side, add a transition, and open this up, and you're going to change this to be on state completed, transition to root. Okay, and that means it's going to go back to the start and go back through the state tree again. So it's a very simple state tree. You compile, and that should be okay. So let's now go into our game through simulate, and now we can see our characters can move around the scene just fine and are following the paths. Let me just turn down my camera speed a bit so you can see that a bit clearer. As such, that and fix that. And in AV Mani, the thing that comes to speed. Okay, so if we go into the game now, we can see our Mass AI wandering around, and you can debug these the same way you do normal AI debugging. If you push the apostrophe key next to your return key on the keyboard, you'll see the mass data working. You can sort of see like the mass.
Yeah, let's take a look at what we see here. They're not doing a great job of ignoring me, but they do seem to be... She's gonna walk into me, isn't she? No, she's not. Okay. They're just completely ignoring me.
AI, and you can see like where it is in relation to the actual actor itself. So arrows are trying to move, what way they're orientating. You can see the smooth orientation is the big yellow line, etc. And you also see like avoidance as well. So if I was push Shift V, they will now show their. I'm going to do Shift O as well. You'll see the avoidance they have. Now at the moment they're going to just avoid each other, not me. So let's just see that in action if I got to it. Also the purple one refers to the one I was looking at when I pushed the button. But looks like it's about to collide with this one. Oh no, too close. Should make it a bit more busy. Let's go to some more over here. Nope. Just trying to get in line up. Definitely should make it more busy. There you go. Right, you can see some debug information. Okay, you can see the Shift C, you can see the path. You should see the path. And show shapes. Shift S. Nope, it doesn't want to show it. Okay, whatever. So I say mass is still experimental. Some things don't work. But there you go. You can see information coming through just fine. And so the main thing we want to add now is make it so they avoid us. So they'll avoid each other. They won't bump into each other. Trying to get an example of that playing. Let's actually increase the count here. Actually, let's go to our spawner and change the count from 10 to 50. And hit play. Okay, so now we've got a lot more of them running around. And you should see that they will like swerve out of the way of each other and avoid each other. Yeah, they shouldn't really collide or bump into each other. But it won't be the same for me. So for me, they will just walk into me and it will basically desync them. So if I go into here, for example, and I block the path of this one, you can see the mass AI circle is still moving, but he isn't. He is now back here. And so they're out of sync. So this one wants to move out of the way, it's avoiding stuff. But the mesh is no longer in sync with that location. Yeah. And that's because we're not syncing the transforms of it. Now, rather than syncing transforms, we make them so they avoid our player. Now, if you want them to avoid things that are other than other mass AI actors, you need to create a new data asset for your player character. So we create in here a new data asset, choose a mass agent or mass ST config asset, and we'll do player config. And open.
Okay, so we're gonna do this. And he said, what was it again? It was data asset. Miscellaneous data asset.
Choose a mass agent or mass ST config asset.
Mass entities big asset. Player.
And we'll do player config. And open this up. Next one's a lot.
Asset. Player.
Simpler than the other one that we've done. The traits you're going to use in here are pretty basic. So on the one here, we're going to do, I believe it's agent capsule collision sync. And we also want to have it be part of the navigation obstacle pathway, like that. So navigation.
Okay, so we don't need any parent. We come down in here, and here we have capsule collision sync. And we want wait. Agent capsule collision sync, yeah.
Obstacle means at this. And we also want to have it be part of the navigation obstacle pathway, like that. So navigation obstacle means that this itself is going to be an obstacle, and capsule collision is obviously our capsule. And
Navigation obstacle.
if I open up, the traits you're going to use in here are pretty basic. So on the one here, we're going to do, I believe it's agent capsule collision sync. Wait, like that. And we also want to, it tells the mass system where we are. And if I open up the thing here, we want to change the capsule collision sync to go from actor to mass. So it tells the mass system where we are. Okay, and the sync transform we do want to update. We want to keep it like that. So with that, and then go to our player character, which is this one here. I'm going to go to add and search for mass agent. And on the right side,
And then Truckcoon. Add.
we're going to choose our parent class, which is the parent asset, which will be the DA player config. And that's it. We're going to hit compile, save.
Okay, we're gonna do a couple quick fixes here because I want to clean this up a little bit here. We're going to our reference viewer. It is not being used anywhere as far as it looks like. So we can just do this and delete. And we can do this and we can do that. And then we can come into here and we can do fix up redirectors. Then we can come back down into here and we can say that. And then we can come back into here and fix, oops. Yeah, fix up redirectors. Oops. Here we go. And then save compile.
Now, these guys, the parent asset, which will be the DA player config. And that's it. We're going to hit compile, save. And now, these guys should also walk around me and not walk into me. So it's trying to debug, it's a little bit easier to see this in action. But you can see them like swerving around me instead.
Beautiful. That's all we had to do. They're not even avoiding me. Oh no, they're trying. I think. Let's do this on a straightaway instead of on an angle. And see if they actually try to avoid me. They're not even trying. Like,
And you see the avoidance is the line, you see the little, I don't know how to describe it, the maroon arrow. That's where they want to go, and it's just like keeping in mind where they are, and they're just adjusting their location based on that. So now these guys will avoid me as I run down this sort of corridor, basically, of people.
yeah, no, I'm just like not being avoided at all.
Which is pretty neat. Okay, and avoidance settings are still available on the NPC, so you can still change how they avoid me and things like that. But we can easily make characters walk around and navigate through all these elements, which is pretty neat. So there you go. We've now got our NPCs. There's an action side. Use our parent class, which is the parent asset, which is the DA player config. When we do want to update, we want to keep it like that. So with that, and then go to our player character, which is this.
Let's rebuild this one here. We'll do that and delete the old one. I am not being avoided. It's not even trying to avoid me.
Yeah. And that's because we're not syncing the transforms of it. Now, rather than syncing the transforms, we make them so they avoid our player. Now, if you want them to avoid things that are other than other mass AI actors, you need to create a new data asset for your player character. So create in here a new data asset, choose a mass agent or mass FT config asset, and we'll do player config, and open this up. Now, this one's a lot simpler than the other one that we've done. The traits you're going to use in here are pretty basic. So on the one here, we're going to do, I believe it's agent capital collision sync. And
We're gonna go through and
Okay.
just fix
Sure.
up this.
And this one I'm going to make just high class. And you can open these up. X1, which entities it should be using instead. Okay, so need these assorted fragments first of all. You can close that, and then we're going to add another one. Okay, so need LOD purposes, which you'll go.
This is correct though. Actor to mass. This should be working. Unless my actor doesn't have it. Let's hit play and double check. Wait. There it is. Our traits should, yeah, our traits are agent capsule sync and all of that, but when we come into here, we can clearly see that they do not attempt to avoid us. I don't think they're even syncing with themselves properly. So we're just gonna rebuild this using all of the stuff that he's got here because I think his worked better. All right, so we're gonna come back into here. I'm just gonna copy and paste this in, so if anybody wants to take a look at it, they can easily. So we're gonna come back to the very beginning here.
Is where we define literally, and a lot of that's going to be first of all setting up where traits we can add array elements to it. And the first trait we can do is going to be an assorted of fragments.
Okay, we're just gonna open this up here.
trait. This is basically what data is it going to go fetching. And if you open this up, you're going to add a few fragments to this. So the first
Okay, first things first, we want to duplicate this.
we're going to add to it is going to be the mass actor fragment. So choose that one, and that's going to basically fetch the actor that we've assigned to be using our mass system, which we haven't done so yet. But leave it on blank, and in there, it looks like we're going to need a few more. The first one next one we're going to add is going to be the transform. So we get the location of the guy walking around, and we also want to get the agent radius fragment, so you know what kind of radius they have. Because when we do collision things, we need to know that information. And you can see that over here, we can change the radius there. And we also need, here, one more, which is the mass viewer info fragment. And this allows you so it can see for LOD purposes, which we'll go over in a second, which entities it should be using instead. Okay, so I need these sort of fragments first of all. You can close that, and then we're going to add another one, which I've actually already done, for index 1 of the traits. So the first index we're going to add here is going to be agent capsule collision sync. This is going to sync up the collision of the capsule the character's walking around in. And you can open these up, and in here we're going to turn off sync transform because we don't want it to move around because of it. We want it just to sync the direction from actor to mass. Mass actor to mass, yeah. We then want to go and add another trait, and this one's going to be agent movement sync. And this one we want the mass AI to move the agent around. So we're going to change that to mass actor. Add another one, and do agent orientation sync. And similarly, you can change them both ways. To mass actor. So once again, the mass AI is telling them which way they should be looking, which way they should be going, and how they should be moving. Okay, so that's getting the data and sending it back and forth, basic data. The next thing we need to do is set up the what is it called? Crowd member. So you click on crowd member. This is so you can identify and tag the actor as a crowd. Okay, and so it just comes in as a crowd member. The next one we're going to add is the crowd visualization. And if you open this up, you can determine which actor is used based upon which LOD system is being used. So LOD system is when your camera is far away from something, it will render something different from what it is if it's close up to something. So the benefit for this is like for performance reasons, if you're really, really far away, you don't want to bring in high detailed actors with complex behaviors on them. You don't really need that stuff. They just need basic things. In this case, we can set what those things, what those types are. So the high res temp actor, we're going to choose my NPC character, which is just a basic character, no code at the moment. So I'm going to choose that one from the drop down list. And from the drop down, we're going to choose my NPC character. And we also do the same for my low res one, because we're not bothering with.
I think this is what I had. We're going to save all here and just make sure. There's exactly one of them now. Love it. 10 out of 10. She works, but there's only one.
In this case, we're then going to go down to the parameters, open this up, and in here you'll see LOD representation, and here you've got what actors are going to be assigned to different LOD settings. So you've got high, medium, low, and off. So as you can see here, high and low are set up just fine for high and medium, but the low is been set to use safe mesh instances, and that is set up so that if it's really far away, it'll just replace it with just a static mesh. It's not going to do anything. So I'm going to go into my high and keep this high res spawn actor, change this one to high res spawn actor, and also change the low to high res spawn actor. And we can close that. And then I want to go down to LOD parameters, and then do LOD max count. And this tells you how many is it going to spawn when it's far away, so how many could it spawn. And we've got 10 for high, 20 for medium, low 500, and off you can have quite a lot. So you can leave it like this if you want. Also, if you want to increase it to this, you can do, but for now, we can leave it as is. But if you want to increase it, that's where it goes. And once we've done that, we can close the crowd visualization trait. Okay, next one. We're going to go in here and add in there's quite a few to add, so let's go to add avoidance. So avoidance is how it's going to avoid other actors on the path, on the lane. So I need that one. The other one is its movement. So click on movement. You'll see how it moves, and in here is where you change out the speed of the character when they walk and move. So it's not controlled by the character movement component anymore, it's controlled by this. Okay, so this is where that will go. And next we're going to have is steering. So you can turn, and again you can tweak the steering that they have in here. I'm going to leave it like that. Add another trait, and we're going to use zone graph navigation, so you can navigate zones. And we can leave it like this, I think. Oh no, we go to lane filter and change any tags to be using the pedestrian or high class tag. We'll make them use both. Pedestrian high class for now, but you can obviously specify this out with different data assets. And the query radius is how far away is it going to look for a lane that's suitable for it. So 500 will be just fine. And close that. And the next one we're going to add to it is going to be LED collector. So this is going to basically fetch the data it has for the LED system, so it can be used for the visualization stuff. Smooth orientation. So if you want to turn smoothly and like interpolate between rotations, you need smooth orientation. And again, you've got settings here we can tweak and change all those things there, but we can leave them as default. Anything else I'm missing? Have a quick look. Grab member, you've got that. If you want to look at something, you've got that there. Oh, navigate obstacle. We need navigate obstacle, so you can walk around objects. And we will need state tree eventually, but we'll do it in the next part. I think that's it for now. So we're going to hit save and close this. Now, again, spawning and using this, we have to go to our NPC and
Beautiful. There is a small problem, and it's around the graph. Because now we want the graph to be more on the ground, because we're actually going to be doing that. So we can just put 0. There we go. Now they're actually on the ground. Like that. Beautiful.
add in our mass agent component. And this is a way to find your agent over here. So kind of person. Now to spawn them into the world, you need to go into your place actors thing, go to all classes and search for mass. And you should see mass spawner. Arrow, or you can add it place in the world. It's an experimental feature, so it's just something that is overlooked and they need to basically get rid of. Basically what it's saying is like those traits that you add, they add their own sort of fragments to it, which conflict with other fragments in other traits that you've already added them. It's just a warning, it's not going to cause any major issues that it has take. So there you have it, we can now spawn in these various NPCs. Obviously they're not moving really around and they're not avoiding anything, they're not doing anything, they're just standing there. So in the next part, we're going to go through and showcase how to make them move around and avoid each other. $1 a month.
Let's come back to here. We'll do the next video.
Hello everyone and welcome back to part 3 of our NPC AI series, where we take a look at the Mass AI plugin and how we can use it to create NPCs that are dynamic in our environment. Now in the first 2 parts we've set up our zone graphs and our NPCs we spawned in, but we're now going to go through the process of making them graph set up. We've got behavior trees. So to do this, all we're going to do is we're going to go back to our NPC config and we're going to add a new trait. We're going to add the state tree trait. If you open this up, you're going to ask you for a state tree. You obviously say none. You can click on this and you can choose a new state tree. And we'll name this one NPC here. NPC state tree. And you're going to click mass behavior. Okay, it's in there now. So if you want to open it up, you double click on the thing there. And you just want and behavior. It should be state trees are just so find one to target first of all. And
Okay, so let's see how this works. Look at that. Here's the view. There we go. Much better. Okay, and then what we really want is if we jump over to our pedestrian low, what we want to do is just add the walk. Then what we can do is we can come over to here and we can do low, low, save, compile. And we can hit play and there we go. We're gonna have to come back and performance optimize these girls a bit more. The answer might just be to replace them with these. But I think the answer is to actually tweak the high reses so the high reses are actually in at a at a bigger distance, because that way that you know. Anyways, we'll come back
this
to
task, if you expand open and expand open again, you'll see you can assign what tags you want to use. So it's going to find a wander target inside the zone graph that you assigned to it. So we do pedestrian.
Wait. Now what
Was
we
that?
were
And
going
another
to do
task.
is we were going to test it. They're not avoiding me.
To it. And this next task is going to be path follow. And we're going to open this up. And we are going to change the target location to ZG find wander target and then wander target location. So basically it does this task first and it sends that task result over to ZG path follow. So it'll follow along the path. Movement style, we'll leave it as invalid. Speed style, we'll leave it like that as well. Now with state trees, you do have to take what will happen after the state's finished. So once it's done this file, and notice what they're going to do as they walk around. Okay, so if we go into the game now, we can see our mass AI wandering around. And you can debug these the same way you do normal. And you should see that they will like swerve out the way of each other and avoid each other. The mass AI circle is still moving, but he isn't. He's now back here. And so they're out of sync. So this one wants to move out of the way. It's hit. Yeah. And that's because we're not syncing the transforms of it. Now, rather than syncing the transforms, we make them so they avoid our player. Now, if you want them to avoid things that are other than other mass AI actors, you need to create a new data asset for your player character. So we create in here a new data asset, choose a mass agent or mass FT config asset, and we'll do player config, and open this up. Now, this one's a lot simpler than the other one that we've done. The traits you're going to use in here are pretty basic. So on the one here, we're going to do, I believe it's agent capsule collision sync. And we also want to have it be part of the navigation obstacle pathway like that. So navigation obstacle means that itself is going to be an obstacle, and capsule collision is obviously our capsule. And if I open up the thing here, we want to change the capsule collision sync to go from actor to mass. So it tells the mass system where we are. Okay, and the sync transform we do want to update. We want to keep it like that. So with that, and then go to our player character, which is this one here. I'm going to go to add and search for mass agent. And on the right hand side, we're going to choose our parent class, which is the parent asset, which will be the DA player config. And that's it. We're going to hit compile, save. And now these guys should also walk around me and walk into me. So it's trying to debug. It's a little bit easier to see this in action. You can see him like swerving around me instead. And you see the avoidance is the line, you see the little, I don't know how to describe it, the maroon arrow.
Why am I not being avoided? Ah. I wonder if it's like a collision thing. It shouldn't. They're not even attempting to avoid me. Oh, wait. Is it me or the other girls that they're trying to avoid? I think it's... Some of them are trying to avoid me. That one tried to avoid me. I think. Actually, maybe not. I think that just might have been the... They're not avoiding me. This is set up exactly
That's where they want to
how
go,
his
and it's just like
is.
keeping in mind where they are, and they're just adjusting their location based on that. So now these guys will avoid me as I run down this sort of corridor basically of people, which is pretty neat. Okay, and avoidance settings are still available on the NPC, so you can still change how they avoid me and things like that. But we can easily make characters walk around and navigate through all these elements, which is pretty neat. So there you go, we've now got our NPCs avoiding us as well as each other, and things are starting to look really nice. But what we're doing in the next part is add some variants and extra behaviours to our NPCs, so not just wandering around, they're actually doing something and reacting to your presence. So we're going to take a look at that in the next part over on patreon.com/Ryan Lady. We can find all my videos early from just $1 a month. Thanks to all my patrons for their continued support in the channel. Make sure you subscribe.
Ever
I think he's not posted it. I don't think part 4 is posted. Yeah. This is maybe these need to be in different order. Um mm, Updating the mass. Inside of the high res actor. Hmm. The avoidance stuff just isn't working. Oh, wait. For mass to work with players and actors that are not spawned by the mass representation, the actors need to have a mass agent component added to them. Open the blueprint used for the default player, add a mass agent component to the character, set its entity to mass agent component to use mass entity. I wonder if I do this and just put these directly here, if it might work. It's like the opposite of what I want, though. Set the entity config to the mass agent component to use mass. Compile and save. Oh, wait. Maybe this needs to be the fragment. Sorted fragment, and then here we do the... Actually, wait, delete. Huh. In the details panel of the... Set the entity config to mass... This is actually what we just did. We just did this. And it's not working. Oh, excuse me. My disappointment in this is immeasurable. Sup, Jack? I'm not. So my agent character here doesn't count. Look at this. Watch this. Watch this. They're supposed to try and go around me. I'll be right back. Truck couldn't save us? Yeah, pretty much. It's not quite working. The avoidance doesn't want to work. For one reason or another, avoidance does not work. like, it's not the end of the world, but I might have to. Okay, so we can see that their arrows for avoidance just doesn't even care that I'm here. He's just like, yeah, you're there, whatever. We're not even gonna try. Fuck it. Yeah, I do know that I have that. Did you redeem one? I have the tablet. Wait, I don't have the tablet installed right now. I'll have to install it. Yeah, as long as whatever it is stream appropriate. So the walk in and flop part, that's expected behavior. I don't know how I want to handle them walking into it. Like I'm thinking that if they get hit at all, right, they're just going to collapse. Right? It is what it is, right? But I would like them to actually make an effort to avoid it. So I was trying to add the avoidance. The avoidance is supposed to be just add this, slap the agent on here, and it's supposed to work. And it's just like, no, that's not gonna happen. And it's just like, but why? Collision sync. We want this to be actor to mass. Yeah. And then here we want the navigation. We want obstacle. We're saying this is supposed to say, hey, I'm an obstacle. Please ignore me. So let's try this. Just for you, sure. Well, that's weird. So wait, what would happen if I come into here? This is, oh yeah, this is the one that I changed. Wait. No. Uh, damn it, all the fucking hell. I feel that, yeah. I'm trying to think because, like, ideally, I want to have. Ideally, I want to have like a massive amount of AI walking around, right? And as much as it sucks, the answer might be don't use mass. Do-do. Mm, okay. Talking about 1,000 AI actors. Okay, I have some ideas. I have an idea to test something. Okay, yeah. This does work. Come up here and we go truck. Okay, there we go. That's fine. Okay, so let's see how many of these girls we can get actually walking around with the lightest amount of AI possible. Okie dokie. Is that the one? Hmm. Supposed to spawn 100 of them. It has spawned exactly none of them. Why is it not spawning any of them? You know what we could do? This could be fun. Let's actually get these guys walking around. Let's get this one here walking around. And then that can potentially just get rid of the problem altogether, right? So if we go to maps here and just load up this map. And we're going to go to project settings. Go to maps and modes and make sure that's the correct one. Sweet. We're going to close that. We're going to come in here. We're going to hit play. And right now we're getting 50, right? But what we want is we want to see what will happen if we get, say, 100 of these girls walking around, right? So it's just not going to work. Okay, so this does not work at 1,000, but it does work at 100. Then if we go to the city map, okay, so if we go to the city map, what we want to do is we want to come over to the mass. We want to change that to config 1. We want to go to our pedestrians. We're going to get rid of this because no need. Pedestrians, we want the mass. We're going to take this config 1, save, compile. Pedestrian low, we want to grab their mass here, and this should be pedestrian 1. Save, compile, and then we hit play. They should be in the ground. There we go. Beautiful. It is actually what we were expecting. Then I feel like it was the transform. Okay, it wasn't that. Ow. Oh, that's why. It's not the one that I wanted. It's one of these. I feel like it's the feet one. That's the one that was. Uh, that solves the problem. It does introduce a different problem, but I think we should probably start profiling at some point here. Wait, there's a mass debugger? Actually, if I go like this, we do this, we then hit play. We can see what's causing this here, yeah. Visibility, move that. Hmm. It's probably because these are both using the same thing. Where's the collision? This one here. Wait. Yeah, that made sense. So if I do the feet, and then I do actor to mass, maybe, what would that look like? No, this needs to be maybe initialization only. Let's try that. See what happens. No, it really wants mass to actors. I did something wrong. Let's try this. That's fucking terrible master actors. Yeah, it's more perfect. It's not my desired situation, but okay. It's kind of okay. We need to performance optimize this, like really badly. Performance optimization in my game. Wait, what is this here? Tools. I don't see the, I don't see it. Navigate for start Unreal Insights from the Unreal editor. Go to Tool, Unreal Insights. Tools, Unreal Insights. I am not crazy. It is definitely not here. Like straight up just not here at all. There it is. that one. That one's a problem. I want to do just CPU stuff because just CPU stuff is the only thing that we care about right now. And just the game thread. World tick. Tick component event. Oh, cloth sims are really what's killing me here. Okay, so it's the cloth sims. Unreal Engine enable/disable. Allow. Now these ones are still simulating claw. But we can fix that, right? So what we're going to do is here, hittable character base, right? To do, no, pedestrian. We want the target here. Then we're going to come down here and we're going to say, enable cloth simulations on the mesh. We're going to test this. Also, Nari, how have you been? While you type that out, I'll be right back. I need more water. we go. Actually, we'll close that. We'll come into here. Stop. Come back into insights. This is the one that we care about. We only care about CPU right now. Okay, so we don't know if we care too much about this one here, because like what's happening? Slate Tech. Interesting. Slate Tick is actually a problem. I think the only thing that's ticking in Slate though is like I really don't think that Tick's doing like the Slate's really doing much at all. I don't know why it's taking so long. Oh, it's okay. So on average it's not. It's just filling whatever the rest here is, right? Because like this is the average Slate tick here. So I think it's just an I think it's just a oddity when it takes that long. Audio's there. Yeah, no. It's pretty minimal here. Uh, Wait, why are these characters ticking at all? Wait, the lows should never tick under any circumstances. Look, the tick isn't even there. Why is it ticking? The physics stuff is really what's ticking it. Interesting. That's unfortunate. Okay, so what can we get here with this mass spawner? Can we even get to 1,000? Holy shit. Oh my god, we can. What happens if we drive away from them? It's god awful and bad, but they're still spawning back in. Okay, so let's do 500. Okay, and then what happens if we standalone game profile? It's probably because there's not enough space for 500 of them realistically, and that's probably what's causing the problem. Still, it's pretty good. It's pretty good. It's pretty good. Let's go to this map here. And let's see what we can get with selected viewport here, right? Oh yeah, I forgot that I needed to move the graphs down. Right? And then if we do Oh wow, 200 is still too many. So yeah, 200 is too many. Oh, sorry, 500 is too many. This is better. I'm kind of curious as to what would happen if I just went to the AI and said, "Hey, stop switching out at for for distances here. Let's laud at higher distances." So now we'll keep them around. Yeah, right now it looks like the best thing to do would probably just be to like Huh. That actually gave me a performance boost. Let's do a build. Let's see how this performs outside of editor. Because right now everything pretty well shows good things. That's why it doesn't work. There's no capsule component. Huh. At least I figured out some of the errors. Unreal Engine allow console enable console in I think it finished building already. How to This configuration enables all but the most time-consuming engine and game code optimizations, which makes it ideal for development and performance reasons. Development configuration by default. Ah, so it's a test build that I want. How do I do a test build? Uh, hmm. Do 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 do. Unreal Engine console in packaged build. I believe the console is stripped from the game. The editor, and I think at least some people will want to ship versions with console and or. Huh. I built this was supposed to be a dev build or whatever, and it doesn't have console. Let's try another build. Yeah. We could do that as package. Try again. Hmm. I really need to remove fmod. I thought I did. Maybe I put it back. Nope. Did you go into a different build? No. It's just not building. Unreal Engine console in packaged build.
Today we're going to be looking at an in-game development console that's available on the Unreal Engine marketplace. The system does cost money, so this tutorial might not be helpful for you unless you own the product or are planning to buy it. Now that that's out of the way, let's get started. The first thing we're going to talk about is integration. So if you look at the content browser, you will see the custom console content if you install it from the Engine marketplace. And inside here we have some main things like the game instance, the UI console itself. Just there in the system, I recommend that hello. I can do clear to clear all the messages on the screen. Here, use it here. It'll tell me the command wasn't found. But if I type test,
Alright, so in this video I want to give you a rough overview on how to go about debugging a packaged game. So, for example, right now, everything just once the packaging is done, and we'll go through the logs, just confirm that there's no warning, no error outside of the executable, ending in debug game. However, still, nothing happens. Now, normally, you would just take this, for example, load it up in Visual Studio, and run as a debugger, which we are going to do. And we packaged before, file, package project, still make sure we're on debug game, we're going to go to packaging settings, and we're just going to search for debug. Come down here, we have include debug files, hit check, and then what we can do is actually just repackage the game, so I'm going to delete mode. Come down here, we have include debug files, package project, still make sure we're on debug game, we're going to go to packaging settings, and we're just going to search for debug.
This is supposed to be a debug version of the game, and it's not a debug version of the game. Yeah, let's try this again. Yeah, no, it's great. I can't fucking I might need to go look for somebody who knows mass. I think we're definitely getting somewhere. Oh, it's so good. Slash absolutely terrible. I still wish that the console would just frickin' work. I just want to be able to type, like, see the stats and stuff like that. Mm. All right. Think we're gonna call it a night and go raid somebody. Anyways, thank you to everybody who showed up, chatted, stuck around, whatever. You are all awesome. I will see you later, and we're gonna go raid somebody. And ta-ta for now.